I want to use this video to explain why we need to study limits. A lot of students feel like they're being forced to accept this new concept, so I think before talking about its definitions or doing any practices, we need to figure out why the limit was created in the first place, and why do we need limit. And the one thing we should know is that when mathematicians cannot solve certain problems with a concept they have created, they start to create new things. This is how the math is developed. For example, x squared equal to -1, we know x equals to plus minus square root of -1. But to make sure x can have a solution, the mathematicians created the imaginary unit I to represent square root of -1. And for this exponential equation, to make sure x can be isolated, mathematicians created the logarithm. So there must be a problem that mathematicians cannot solve, and that problem pushed them to create this new limit notation. I don't think they are purposely trying to make math hard, it's just they had no choice. So what is this problem? I want to use myself as an example to start. This is a picture of me, and my name is Mr. John. I have a dream, which is to become a millionaire at the age of 50. And now if I want to express my dream mathematically, can I say Mr. John equals to a millionaire? The answer is probably no, because I'm not a millionaire yet, so I cannot use that equal sign. But since I'm approaching my dream, the approaching sign looks like a better choice. So for the dream I'm approaching, this arrow is the correct notation. So now let's take a look at the math. Functions, they have dreams as well. As you know, this is the inverse function approaches 0 when x approaches infinity. But just like my dream, the equal sign cannot be put there because f of x never achieves 0. The approaching sign is a better choice. So it looks like when we want to show the value we're approaching mathematically, our only choice is the approaching sign, not the equal sign. But there's an issue. There's a problem with our approaching sign. When we have equal signs, we can do further calculations. For example, x equal to 2, y equal to 3. We will be able to calculate the exact value for x plus 2y by simply plugging the numbers. But if we have x approaches 2, y approaches 3, we will not be able to calculate the exact value for x plus 2y because we don't know the exact value for x and y. And not being able to do further calculations, this approaching sign is kind of useless in lack of mathematical meaning. So the mathematician, they start to realize that this equal sign is really, really important. We need this equal sign to calculate the approaching value, and this is the problem the mathematicians were facing. They really want to build connections between the approaching value and the equal sign. But so far, nothing there they can use to achieve that. They have to create something new. And this process of creating new math concept takes around 2,000 years, from the early effort looking for the exact value of an area of a circle all the way till 1870s, when this German mathematician finally put this equal sign here. But with a price, and this price is adding our new friend's limit notation. So now we know this limit notation is not an operation, it is just a notation to put this approaching value and the equal sign together. And also it's never the main character. The equal sign is the main character. That is what the mathematician really want. So before it was Mr. John approaches a millionaire, and now it is Mr. John equals to a millionaire, but with the limit at the front. It's more complicated, but hey, there's an equal sign, and that's all that matters. The whole subject of calculus would not exist without this small innovation. As you can see, with this limit notation, we can have equal sign, and then we can do further calculations. All the topics of calculus need to say thank you to the limit notation because it brings the equal sign. So now let's get back to this function. We can finally say f of x equal to 0, but with a limit notation at the front. X approaches infinity. Okay, so hope this video helps you understand why the limit is created in the first place. It's all because we want the equal sign.